Welcome back, Wolfpack. Today's lesson is a continuation of 13.1, which is on the tangent ratio. And today we're going to be talking about the sine and cosine ratios. Your lesson objective continues to be, how can you find a missing side or angle of a triangle? And your content objective is that you're going to be able to find the missing side or angle of a right triangle using the trigonometry functions of sine, cosine, or tangent. Today specifically focusing on sine and cosine. So, the sine of angle A is the length of the leg that is opposite to angle A and the length of the hypotenuse. So the sine is the opposite over the hypotenuse. Opposite over hypotenuse. Okay, opposite, hypotenuse, sine. The cosine of angle A is the length of the leg that is adjacent to angle A over the length of the hypotenuse. So cosine is adjacent over hypotenuse. So if you remember yesterday or last class we did tangent, and tangent is opposite and adjacent, O and A. Sine and cosine both deal with the hypotenuse and then either the side that's adjacent or the side that is opposite. Okay? So for as an example, if I was working with angle A, okay, the sine, so sine of angle A is opposite, which would be CB, over hypotenuse, which is CA. But if I was doing the cosine of A, it would be adjacent, which is BA, over hypotenuse, which is CA. Notice that CA is the denominator in both times, but sine is opposite and cosine is adjacent. And that phrase, and I told you last class, is SOHCAHTOA. This is not something I've made up. This is something that is widely taught by geometry teachers across the world. Okay, SOHCAHTOA. S is for sine, and then we have opposite and hypotenuse. C is for cosine, and then we have, I should do blue. Okay, let's try this again. Okay, so S is for sine, and then we have opposite and hypotenuse. C is for cosine, and then we have adjacent and that should be green, sorry, my marker messed up. Adjacent and hypotenuse. And then T is for tangent, which is opposite over adjacent. Okay? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So each one gets used twice throughout these three trigonometry functions, okay? And here's the formula. The sine of angle A, and this is a Greek letter that we use for angle, especially in upper level math. The cosine of the angle and the tangent of the angle. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and again, tangent is opposite over adjacent. Okay, moving on. Example 1, find the following ratio. So right now, all I'm going to have you do is put them in as a fraction, and we'll work on them as decimals probably in class. So I'm going to go ahead and again, I'm going to write that phrase at the top. It's a good idea to, whenever you're working this out, simply write SOHCAHTOA at the top of your paper so you don't forget. So the sine of angle A, so this is the angle I'm working from the perspective of A. I need the opposite side. So this side is opposite angle A, and the hypotenuse, which is always the side across from the right angle. So opposite, 10 over hypotenuse, 26. Okay? So now I'm dealing with the cosine. I'm still from the perspective of angle A. The cosine of angle A is adjacent, this side, over hypotenuse. And the hypotenuse is always the hypotenuse. That does not change, regardless of what angle you're looking from. The perspective of the angle does not matter. The hypotenuse is the hypotenuse is the hypotenuse. Okay? So now we have from the perspective of angle B, and I want you to go ahead and pause this video, and I want you to see if you can write down the ratios for the sine of angle B and the cosine of angle B, and then check your work. Okay, so from the perspective of angle B, CA is opposite the angle, CB is adjacent to the angle, and BA is the hypotenuse, and it's the hypotenuse regardless of what the perspective is. So the sine of angle B is 24 over 26, and the cosine of angle B is 10 over 26. Hopefully you got those right. Cofunction identities, okay? Cofunction identities are meaning that they're going to equal the same thing. So the cosine of an angle is the same thing as the sine of 90 minus that angle, okay? These two things are equal to each other. So for example, the cosine of 30 is the same thing as the sine of 90 minus 30, which is 60, okay? So the cosine of 30 is the same thing as the sine of 60, well, because 30 plus 60 add up to 90, okay? So the cosine of 1 is the same thing as the sine of 90 minus that 1. Now, that does not mean, tangent does not come into effect here, okay? This is only with cosine and sine. And the opposite is true as well. The sine of an angle is the same thing. It's going to equal the cosine of 90 minus that angle, okay? So this is 50. So the sine of 50 would be the same thing as 90 minus 50, which is 40. Okay? So if you were to press 50 on your calculator and press sine, and then 40 on your calculator and press sine, those two numbers would be the same thing. So here's an example right here. Okay? If you press 42 and then hit the cosine button on your calculator, you get 0.743 on and on and on and on. And the reason why this sign is here, this means approximately. So the cosine of 42 is approximately 0.743. Well, 90 minus 42 is 48 degrees. The opposite of cosine, or the cofunction of cosine, is sine. So if you take sine, the sine of 48, because again, 90 minus 42 is 48, so 48, and you hit the sine button, you also get 0.743 on and on and on and on and on. So if you don't believe me, check it on your calculator, okay? So as an example, the cosine of 25 degrees would be the same thing as the sine of what? Well, what is 90 minus 25? That is 65. So these two equal the same thing. On your calculator, 25 cosine is 0.91 to the nearest 100. And 65 sine, 65 sine is also 0.91 to the nearest 100. Okay, so check it out, play around with it. They are the same thing though. Example number 3, find the length of the hypotenuse. 3a, find the length of the hypotenuse. So this is the angle that we're working with. Okay, so from the perspective of that angle, let's label the sides. Well, this is opposite. This is the hypotenuse. I'm going to write down my phrase. I have opposite and hypotenuse, so I'm going to work with sine. So sine 15 equals 7 over x. Okay? Opposite over hypotenuse. Remember, we talked about if x is in the denominator, we can rewrite it by saying x equals 7 over the sine of 15. So we solve that. 7 divided by 15 sine. Press the equals button. Let's run it to the nearest whole number. So x equals 27. So the length of the hypotenuse is 27. Let's do letter B. From the perspective of this angle, 36, we know this is the hypotenuse, this is the adjacent side. So SOHCAHTOA, we have adjacent hypotenuse, so we're going to be dealing with cosine. So the cosine of 36 is the adjacent 29 over the hypotenuse, which is n. since the variable's on the bottom, they can switch places. N equals 29 divided by the cosine of 36. And they're switching places because if we were to multiply by n, both sides, and then divide both sides by cosine of 36, this is what we'd end up with anyway. Okay? So 29 divided by 36 cosine, then press equals, to the nearest whole number, you get 36. N equals 36. Okay, and obviously the directions don't tell you how to round, that's why I rounded to the nearest whole number. I would love for you to try it on your own before class and see how you did. So if you want to attempt that, that would be great, and you'll be further ahead. And we will do example 4 in class as well. Again, if you want to try these ahead of time and be prepared, you totally can. You need to find x and y, so you're going to do the sine of one and the cosine of another. Okay, so now this is finding the angle. When you're given the two sides and they want you to find the angle, you're going to use the inverse functions. We did inverse tangent before, now we're doing the inverse functions for sine and cosine. It's still the same ratio, opposite of hypotenuse and adjacent over hypotenuse, but you're going to use the second feature, so that way we can do the inverse, okay? Oh, and there's my cute little daughter. Isn't she adorable? She's in church. Andrew said that I needed to put something fun and interesting in the lesson, so here's an example of something fun and interesting. I love my daughter. She's a cutie. There you go. One of my twins. Use the calculator, example 5, to approximate the measure of each angle to the nearest degree. So we're looking for the angle right here, okay? So we don't know the angle, but they actually already gave us this ratio right here. They actually, instead of giving us numbers such as like 25 over 74, they went ahead and solved it for us. So all you have to simply do is type in 0.76 and do the inverse sine. So second sine, okay? And you can press equals, but shouldn't change anyway. And so that would be a nearest degree, which means you round up 49 degrees, okay? Same thing here. They're wanting you to find the angle. They already gave you what the ratio divides out to be. So you type 0.17, inverse cosine, so second cosine. You can press the enter button if you want. That doesn't change anything. To the nearest degree, so 80.2 just becomes 80 degrees. Okay? We're going to do one more example, and then we'll stop for the day. Find angle x. So from the perspective of this angle, this is the hypotenuse, and this is the opposite side. So we're going to do the inverse sine, because we are dealing with finding the angle, opposite 24 over hypotenuse 29. So on your calculator, 24 divided by 29, make sure you press equals, because you're finding out what 24 divided by 29 works out to be. And your calculator should say something like 0.8275. And then you're going to do inverse sine, so second sine, and your answer is 55.85, or to the nearest tenth, it's 55.9, or to the nearest degree, it's 56 degrees. Okay? If you want to try letter B on your own, go for it and see if you can get it right. Thank you guys for doing your best. Please make sure that this is done properly, and I will see you next class. Have a great day.